All right, let's dive in. Today, we're going to look at something you've probably seen a million times. That simple little security sensor on a door or window. And it seems pretty basic, right? It's either on or it's off. But hiding inside that tiny plastic box is some seriously sophisticated logic that lets it be way, way smarter than you'd think.
So here's the big question. These sensors, they run on just two little wires. But somehow, the alarm panel knows if the door is secure, if it's been opened, if somebody cut the wire, or even if a burglar is trying to short those wires together to trick the system. How is all of that information coming down the exact same two wires? Well, it's not magic, it's just some really, really clever electrical engineering.
You know, the secret to all this really boils down to two basic ideas for how you can build a circuit. And you can think of them like this. One is like a chain, and the other is like a ladder. If you get the difference between these two, everything else is going to click into place.
So first up, you've got the chain, which is what engineers call a series circuit. Everything is connected in one single line, one after another. The important thing is, if you break any link in that chain, the whole thing goes dead, kaput. Then you have the ladder, or a parallel circuit. Here, everything's connected like rungs on a ladder. This gives the electricity a bunch of different paths it can take to get from one side to the other.
Okay, so let's put that first idea, the chain, to work. When you're talking about a burglar alarm, what do you want to know? You want to know if anything in your secure perimeter has been broken, right? The chain is the absolute perfect tool for that job. So to build this chain, security sensors are designed to be normally closed. All that means is that when your door is shut and everything's safe, the switch inside that sensor is closed, and it completes the circuit. Electricity is just flowing through it, nice and steady, like a quiet little heartbeat telling the alarm panel, we're good, we're good. So what we've done is build one continuous electrical chain that runs through all our doors and windows. If a bad guy opens the door, that little switch opens up, and bang, a link in the chain is broken. If they just cut the wire, same thing, another broken link. Either way, the chain is broken, that electrical heartbeat stops, and the alarm panel knows instantly something is wrong. Super simple, right? And totally effective. But wait a second. What works perfectly for burglars is actually a terrible idea for fire alarms. If we used that exact same broken chain logic, we'd have a huge problem on our hands. So, what's the issue?
Just think about it for a second. With a fire alarm, you can't have the fire trucks rolling with sirens blaring every time a maintenance guy accidentally snips a wire in the ceiling. A cut wire should just be a trouble signal, something to fix, not a full-blown emergency. This means our broken chain logic is just the wrong tool for this job. We actually need the opposite. So the solution is a normally open circuit. Now, in this setup, all the smoke detectors are just sitting there, day to day, with their switches open. They aren't even really part of the circuit until they detect smoke. When that happens, the switch closes. It creates a brand new connection for the electricity, and that's the signal for the alarm. So let's just put them side by side, because this is the key. For a burglar alarm, an open circuit, a broken chain, means danger. For a fire alarm, a short circuit, a suddenly closed connection, means danger. They're total opposites, and each one is perfectly designed for its job. Okay, so far so good. We've got on versus off, open versus closed. But that's still just two states, right? This is where the real genius comes into play, with one tiny but incredibly important little component that turns a dumb switch into a truly smart sensor. See, there's a pretty big loophole in our simple broken chain burglar alarm. A smart intruder could just find the wires running to a door, strip them back, and twist them together. The alarm panel now sees a closed circuit again and thinks the door is totally secure, even while the burglar is walking right through it. We've got to find a way to detect this kind of cheating. Which brings us right back to our big question. But now it's even trickier. We need the alarm panel to see not two, but three totally different states, using the exact same two wires. I mean, how is that even possible? And the answer, believe it or not, is this number, 2,200 ohms, or what we call 2.2k ohms. A tiny resistor with this specific value gets put at the very end of the sensor loop. Now, the alarm panel isn't just looking for on or off. Nope. It's looking for this exact electrical signature. This is the secret all-clear signal. Okay, so check this out. This is how it works, and it is so clever. 1. When the door is closed, electricity flows through that resistor, and the panel reads a perfect 2.2k ohms. That's our secure state. 2. If the door opens or the wire gets cut, the circuit breaks. Now the resistance is basically infinite. That's our alarm state. And here's the best part. 3, if a burglar shorts the wires together, they actually bypass the resistor. The panel sees 0 ohms, and that's a tamper signal. 3 unique states, all thanks to one clever little resistor.
You'd think that's the end of the story, right? 3 states is amazing. But what if I told you we could take it even one step further? For really high security areas, we might need even more information. And this is where the circuit does its final and most impressive trick. So, is it even possible to squeeze more intelligence out of the same 2 little wires? Could we get it to tell us the difference between a wire being cut versus a door just being opened? Because with one resistor, both of those look the same, infinite resistance. But what happens if we add a second one?
Well, it is possible, and it's called double end-of-line or DOL wiring. It sounds complex, but the idea is just brilliant. We keep our first resistor in the chain, but we add a second one, like a ladder rung, right across the switch itself.
And boom, this is the magic. Look what this gives us. The panel can now see 4 distinct states. When the door is secure, it sees just that first resistor, 2.2k ohms, normal. But when the door opens, the electricity is now forced to go through both resistors, which adds up to 4.4k ohms, a very specific door open alarm signal. If the wires are shorted, we get 0 ohms, that's a tamper. And if they're cut, we get infinite resistance, which is now a trouble signal, not an alarm. It's just a perfect system. So yeah, the next time you walk past one of those little plastic boxes on a door, you'll know about the incredible amount of problem solving that went into its design. It's just a perfect example of this hidden elegance you find in everyday technology. Because that's really what's going on here. This is the big idea. A modern alarm panel isn't just looking for a switch to be open or closed anymore. It's listening for a very specific electrical note. And any change from that note, whether it's higher, lower, or just gone completely, tells it exactly what's wrong.
So, just to wrap it all up, what are the big takeaways? First, series circuits, our chains, are perfect for burglar alarms where any break in the line is a problem. Second, parallel circuits, our ladders, are great for things like fire alarms where making a new connection is the problem. And most importantly, resistors are the magic ingredient that turns a simple switch into a smart sensor that can report multiple different problems and can't be easily fooled.
Just think about that for a second. All of that intelligence, secure, alarm, tamper, trouble, it's all packed into a system with just 2 wires and a couple of pennies worth of resistors. It really makes you wonder, what other simple things that we see every day are hiding a similar kind of secret genius?